And then we're going to go from that, and we're going to continue on, or we're going to do a review, excuse me, instead of a normal 4-6 homework assignment. We're going to do a review assignment that has some 4-6 on it. And then we'll be starting our test Monday. And, yeah. Yeah, Kaylee.
Miss Nicola come in and like tell you to start doing learning targets, or did you just like start saying?
I was asked to by the administration, yeah, to start putting some learning, to put the SWBA. I already put my learning targets up there. I've had those up there all year. I was asked to include the SWBA part. I'm like, okay. So, wow. I was asked to include something on there with it. And so,
Just she came in and started like telling.
hey, what's SWBA stand for, guys?
Wait,
Yeah, the administration asked me, hey, will you put that up there? Sure, no problem. So, it's not bad. Yeah, it wasn't like, oh, I have to do that. No, it's like, it's 4 extra letters. That's right every time. Well, not bad at all.
And you have to underline.
So, hey, I choose to underline. So yeah, like, so I was already like right there. I just needed to add that in. I'm like, okay, I'll add that in. Okay, done. Hey, so we talked about this idea of congruent triangles. We had congruent triangles before. Now we have similar triangles. We're gonna say instead of being congruent, they're gonna be similar, which can be different than congruent. So congruent or congruent symbol. And don't forget we have the tilde. Aubrey, how are your tildes today? Not as good, or are they fired?
Yeah.
Oh, I'm sorry. So.
I'm sorry. How much is that?
I won't die.
That didn't make any sense.
Yeah, it doesn't make sense.
He said, I want to die.
Okay.
Evan?
I am.
Chop it up.
Yeah, that's a mistake. Chop that up.
Are you writing him down? There's no way we're at 9 today.
Yeah.
You're making that
You
up.
made like 3 mistakes during the homework.
Yeah.
Yeah, and I said I was doing something, and you did like.
Oh,
Go back over that.
Yeah, that's fine.
I have a good enough self-confidence.
Oh no, you have
I was watching Office.
What are the five?
I was watching The Office yesterday while I was creating it. Okay,
That's why nothing's done.
There, it took so long for the test to be put in.
What?
It was pretty bad. Actually, Mr. Howard does it in like
Just
5
put it in.
minutes,
Just
so-
put it in.
Seriously?
Just
I
put it in
got
straight
it.
out.
Whoa! I got it back to you by your guys' next class.
I took a quiz.
Mr. Howard,
Pretty great.
I took a
No.
quiz in Austin today,
Ah.
first hour, and I had my grade 5 fit.
Okay. Might be easier to grade Spanish than that.
Mr. Howard did this
Definitely
today, like, in the period you did.
No, American
I took
history
my
is
test
ready in 3 weeks. Mr. Howard.
See, okay. Some teachers say 3 weeks, and you're upset about mine being back to you within the next class day.
Well,
Mr.
I knew I
Shorter
was
is
gonna
the
do
best
that.
at grading,
I
and just
knew
don't
that.
ask me.
Well, you know, some people are fans and stuff.
We have an
and-
Hi,
expectation.
Furious. Nice to meet you. I'm Mr. Consul.
Okay, we
Yeah,
see
you're
you
doing
broke.
good, Mr. C.
See, you
Next
broke
class.
our expectation.
Thank you.
Can we all agree that Mr. Howard is the greatest
I'm
teacher of
not
all
even a
time?
teacher. I can agree. I feel like.
We grade our own homework.
Howard is the GOAT. Howard
should be
for president.
graded. I just want to die. And it's like.
Howard
Right?
for president.
I'm Josie.
Hey, voice is off. So, congruent polygons have the same side lengths. They also have the same angle measures, correct? But we're going to focus on the same side lengths. Now we have this idea of similar polygons. We're just going to use the tilde, so it's like the congruent symbol but without the equal sign now. It's just the tilde. Similar polygons have the same angle measures, but they can be different side lengths. Yeah, I'm sorry, this space is like that. Well, then don't write it out.
have to write your hand.
That's a really good tilde.
But is it perfect?
It's not
It's
perfect.
not. It's
Feel
not.
that.
I really choose. Okay.
I'm gonna start.
So, voices off, please. For similar polygons, corresponding angles are still congruent, just like in congruent polygons. Corresponding angles are congruent. Same thing. And instead of the corresponding sides being congruent and having equal measure, the ratio of corresponding sides are equal. The ratio of corresponding sides are equal. In this figure, triangle ABC is similar to triangle DEF. That's what that symbol will mean for us. The tilde will mean here is similar. Triangle ABC is similar to triangle DEF, meaning all corresponding angles are congruent. We know that. Angle C and angle F correspond congruent. Angle A and D correspond congruent. And angles B and E are corresponding and congruent. But the sides aren't the same length, correct? We're saying the ratios between the sides will be though. You guys know what a ratio is? Okay. It's a fraction with some extra meaning, basically. It's essentially a fraction with extra meaning. Okay? So, it can be like the ratio of students to staff is, I don't know, like 18 to 1 or something like that. I don't know for this school exactly. I'm making up a number. So that would mean if the ratio of every 18 students, you do not have to write this down, for every 18 students, there is one staff member. So that means if there are 36 students, how many staff members are there? Two. So with ratios, we can just keep increasing them. So that's the difference between a ratio and a fraction. With a fraction, you wouldn't want to just keep increasing necessarily. We would want to simplify it. But with the ratio, we could keep increasing. Okay? And you can figure out pretty easily, oh, if this doubles, this one's going to double. Yes, Jacob?
How many staff members are there?
I don't know.
Not enough.
Okay? So, we're gonna get in the habit of putting the small triangle over the big triangle for our ratios. So when it comes to our ratios, we're gonna put the small triangle measure over the big triangle measure. We're gonna put the corresponding sides in a ratio and a fraction. So if I say the length of 4, that's side CA, correct? What side does that correspond to in the big triangle? FD. And what's that measure? 8. So we're going to say that 4 over 8, the ratio of this small triangle, the small side to the big side, is going to be equal to the next one. So we want to give me another ratio. Ian. Very good. Hey, good correction there. You started saying 6 over, and then you realize, oh wait, we're doing the small one on top. We have to be consistent. Could we do the big one on top? Yeah, but we have to be consistent doing it that way. Somebody give me the third one. Evan.
5 over 10.
Yes, it would be 5 over 10. And what do these all simplify to? 1 half. So are all the ratios equal? Yeah. So the triangles are in fact similar. You can, you don't have to. I would actually, yeah, I would box that one. Sorry, I would box that 1 half. Thank you for asking. I feel like Marshall Lynch. Thanks for asking. Okay, Kaylee.
I think this is I think that's a really good.
That's pretty
I
good.
said that was pretty good. I
That's
asked
like-
if it was perfect because Aubrey said hers was perfect.
Aubrey's was like literal perfection.
Yeah, like I.
Yeah.
I don't think I could even.
I kind of want to look
Her
at it.
face was just beaming.
I
down.
heard you guys
She
talking
was-
about that. I just heard Tilda and Aubrey. I didn't know actually.
It was
you guys were
perfect. She
talking
made like
about
back
it.
to back.
You missed
Perfect.
a lot. Yeah, when Jacob
Tilda.
listened to it, he just heard me go, "Oh my gosh, where's Jacob?"
Yeah.
Because I said like,
I
was
noticed
like,
it.
freaking,
I
I
looked
voice
at
is freaking, and I was like,
Wait. It's funny. Alright, so questions about this first part here, kind of the top half of the page.
"Where's Adrian?"
Is it like easy?
So if we go right below this, were you actually asking a question about this? Okay. So for the figure above that, it's on the previous slide now, but you guys can still see it. You're going back and finding it.
Yeah.
We can write a similarity statement and a statement of proportionality.
Right?
Okay? So our similarity statement is kind of like a congruent statement. If you recall, I was like triangle something is congruent to triangle something. So instead of congruent, we're going to say they're similar.
He's trying to make a good one.
I put more effort in that one, yeah. So triangle ABC is similar to triangle.
We can have long first.
Oh, excuse me. So if I made it earlier, it was triangle ABC is similar to triangle DEF. So if I change it, I make it triangle ACB. That'd be similar to triangle what? The one we already did. The triangles we've been talking about. Yeah. It's okay. It's okay. Sorry.
She's gonna go. She's gonna show you, and then she's
Oh,
gonna
there's
go.
So we can also make what we call a statement of proportionality. A statement of proportionality will be saying which side lengths or which sides would fit where in the ratio. So before, we started off with 4/8, correct? If you look in your notes, okay, right above there, we started with 4/8 for those ratios, correct? Which side was the length of 4/4? AC. And what was 8/4? FD. So it was AC over FD. And that was equal to what we did 3/6 next, correct? Okay, what side was 3? AB over, yep. DE, doggo elephant. Okay. And then what was the last one? CB over FE. Could we write EF? Yeah, do the same thing, right? Okay. So this is what we call a statement of proportionality. We're just saying the ratio between these two sides, these corresponding sides, from the small triangle, big triangle, is equal to the ratio of these two sides, is equal to the ratio of these two sides. We're saying all three ratios are the same. You okay there, Jacob?
No, I'll read the next problem.
I just cracked my neck.
Hey, I don't like number one. We're gonna cross number one out. I don't like that one. Good vibes only, you know? Okay. Okay, so on 2, list the corresponding sides. So on this triangle, well, what are some sides that are corresponding here? Somebody tell me a pair of corresponding sides. Raise your hand and tell me a pair of corresponding sides. Ian.
5/15.
I want the sides of the length, sorry.
AB over DE.
Side AB and D. And you're jumping to the portion, which I think is awesome. We're actually into that in the next step. So we're just listing which ones are corresponding right now. Okay, Jacob, can you give me another pair? Side DF and side AC. Very good. And we have one more pair of corresponding sides here. Okay, Aubrey. Side BC and side EF. Very good. Pancreas, I don't stand a chance, you know. That joke gets old, you let me know, okay? And then I'll keep making it another month or so. And we'll do it tonight.
Where's Adrian? We lost her.
Yeah.
Oh, speaking of Adrian.
There she's at.
Adrian!
Hello. You were asking about.
Oh, sorry. Aubrey!
Aubrey, yes, that's me.
So, now the ratio of corresponding sides, we want the lengths now. We want the lengths. So what triangle we're going to put on top?
Little.
The small triangle over the big triangle. If you want to call it L over B for little or big, you can.
L.
Okay. If you want to call it L for little, you can. But I put S.
I like
Small.
Stockton.
Yeah, they're little.
And Stockton over Coach That's in the butt.
Okay, so
Stockton over Brett Schuler.
Stockton over Aiden.
you have that for it though.
Coach, you actually knocked me over today. That's
Two
Nice.
I think
Hey,
you got
so
it.
somebody give me a ratio of side lengths here.
Oh, I got one.
Okay, Josie, go ahead.
5/15.
Money.
Genius.
Somebody give me another one.
12 over 36.
Okay, somebody give me the last one.
10.
What's the first one simplified to?
1/3.
What's the second one simplified to?
1/3.
What's the third one simplified to? Are the ratios the same? Correct. So that'd be the simplify area. Now, we call this the scale factor. We call this a scale factor. We'll say the big triangle is decreased by a scale factor of 1/3. It's like you took the big triangle and you took every side length, multiplied by 1/3, and we got the new triangle. You could flip it around and say the little triangle is increased by a scale factor of 3. Very good. Because if you were to put big over small, this would be 3/1. So you could say this from the little triangle to the big triangle, that'd be increased by a scale factor of 3. Big to little, decreased by a scale factor of 1/3. So it's saying like, hey, we're just going to scale it. Have you ever heard drawn to scale, or objects are not drawn to scale, that kind of thing? So that means they aren't proportional, or they aren't correct. Yeah, you see it on cereal boxes a lot, right?
Yeah.
Okay.
It'd be like ginormous, like,
Yeah, because it'll be like a massive like Reese's Puff, something like that, or like on the front. But they aren't that big, right? Okay, we wish sometimes
think
that would be.
I think
Because
it's hilarious that they have to put not.
Putting the covers into it.
otherwise they'll be sued, because this is America.
They open the book.
What? Lay's chips.
Yeah.
Nolan Cherry.
Cheerios, not.
Yeah. So a lot of different food products, especially, right? Not actual size, something like that. So they'll often take the same proportion, but then blow it up or shrink it down. Usually they'll blow it up, and so it's increased by a scale factor. So that way, all the sides are staying proportionally the same. If it's a shape like a triangle, it would be all the angles would stay the same, but it just gets bigger.
People also do that with
So you increase. Yeah, so people do it with Photoshop where they'll make every side and make it the same amount bigger proportionally. That's called our scale factor. We scale it. Bigger, smaller, factor multiplying. Okay? And once again, we can say that triangle ABC is similar to triangle DEF. And then, what's our ratio of perimeters? Well, let's first talk about the idea of, hey, what's a perimeter again? Okay, the distance around the figure, right? The sum of all the sides. So, what's the perimeter of this small triangle?
27.
5 plus 12 plus 10 is in fact 27. What's the perimeter of the small triangle? That's what I meant, yeah. 81. So if we take the small one over the big one, does that simplify?
Yes.
To what?
3, 9, and then 1/3.
Okay, so you could make it like 3/9 if you divide them both by 9, which would then simplify to 1/3. What do we notice about this, the ratio of the perimeters compared to the scale factor?
It should be the same.
It's the same. Okay? So, it's the same as the scale factor, okay? Hey, let's go to the next page. Let's go to that next page, please. Yes? Yeah, that would still be right. Is that what you did?
No.
Okay, you're just a rebel.
Yeah.
Okay. So, are congruent figures also similar to each other? What do we think? Are congruent figures similar to each other?
Yes.
Okay, we're thinking yeah. Okay, let's explore this. Let's walk through an example. Are these figures
No.
congruent?
Yes.
Okay, they have the same side lengths, and their corresponding angles are congruent as well. Okay, so their angles are congruent. Let's check out the ratios of the corresponding sides, because that's going to be our test. We need angles to be congruent, corresponding angles to be congruent, we need corresponding sides to have equal ratios. So if we take this triangle, let's just call this triangle 1 and triangle 2. If we do 1/2, 4/4, 5/5, 3/3, equals to 5/1. So are the ratios the same?
Yeah.
Yeah. So congruent figures are also similar. They just have a scale factor of 1. I got you guys all inside your head there. You guys were like, if he's saying let's explore, that means we're probably wrong, so it's not.
That's not
I know, and then you
not
choose
us, that's
right.
Aubrey.
Yes, at first I was like, wow.
They're like, oh,
I don't know.
you're like, oh, throw the pad up and have it go behind the board.
That was a big hoop.
That's not
Did you
us.
hear that on the video?
Yes.
Determine whether the polygons are similar, and if they are, write a similarity statement and find the scale factor. Okay, so we need corresponding angles to be congruent and the ratio of the sides to be the same. Okay, what do we want to test out first? Corresponding angles congruent or ratio of sides be the same? Okay, so let's do a ratio of sides. Josie, start us off.
I don't know what.
Ratio of
So do like side A, B, and D. Okay, A, B.
So, like with
So
the
you
numbers,
say
honey.
5
Over 6.
over 6.
And now do another, pick another two sides.
Okay, then 5 over 6. And then 3 over 4.
Well,
Okay, who has a calculator with them?
I do.
I have
Okay,
one.
get it out. Okay? Get it out. If you need to, go up and grab one actually real quick. Okay? Got some calculators up there. They're not
Like,
oh, so nice of you, Audrey.
Are there questions?
I know you're
That's
supposed to go
not
ahead.
true.
This is my. This is my.
Aww.
How old are these? You picked these like months ago.
No.
Yeah.
These are the ones I picked the other day. And I picked them like fresh for the quiz, you know? I'm
You
afraid
have
the
to
right
put
one.
nice clothes all the way from the rest of this page.
Quiz I didn't
No,
take.
it says put your waist more.
Okay, good. I'm
You're kidding, right?
No, look at your text.
I will. You took your.
13.
I got my calculator.
Are you kidding me?
Ian, let me see what I
You don't want, not so frustrated.
Okay. Mr. Riley's.
Okay, so let's do these. 5 over 6 is what? What decimal? 5 over 6 is what decimal? 5 over 6 is?
Come on.
18333.
Those are equal. What about 3 over 4?
0.75.
Are these equal?
No.
So are the triangles similar?
No.
And how else could we have known? Corresponding angles. Are they congruent? No. We also could have known by the corresponding angles. So we could also say angle B is not congruent to angle E, and angle C is not congruent to angle F. So you could use any one of these reasons, any one of these reasons I just circled, for them being, or any one of these two reasons, or this third reason that we did together would work. I just circled a lot. Any of these three reasons, they're all actually help.
JD was more frustrated.
Okay.
Terrible.
Yeah.
You had to make sure I didn't say the band.
So any of the green circles could work as an explanation. You don't need any. You don't need more than one. But any of the three could work. Because this is your answer. You need the pink as your answer, and then one of the green.
Do we just circle it too, or do we just keep it up there? Like, do we just circle the explanation, or do you?
I would probably see it, but I would prefer it circled. Does that make sense? It'd be easier for me to find it. Okay. Questions on that? Okay. Moving on. Find the missing length of the triangles in each problem if they're similar. Let's go to the second one first. Okay, so we have two of these here. Let's go to letter B first. So the matching dots are going to be congruent angles. Do these dots match? So they're going to be congruent angles. Okay, so we can draw an arc there. Okay. Those were the pictures that were already.
Is this something the AC
printed before? I'm like, ah, shoot. Josie, why do you think D would equal 12?
Because if 5 times 3 equals 15, then 4 times 3 equals 12.
It will. It will equal 12. Because if they're similar, we're told they're similar. So if this has to increase by 3 to get to there, this one has to increase by the same scale factor. Okay? And here's how we can mathematically figure that one out. We can do a proportion where we have two ratios together. So we get 5 over 15 has to be equal to 4 over D. What do you do when you have two fractions equal to each other? Boom! Cross multiply. 5 times D is 5D, and 15 times 4 is 60. That's a shakehand one for me. I just go to that one, I suppose. So what do we do now?
Divide by 5.
Okay, and it was 12, just like Josie said.
Smart.
Okay? Hi, smart. Mr. Carlson, nice to meet
See,
you.
someone says I'm smart.
Well, I mean, you said you were smart.
Well, you just said it back to me though.
So, okay, if we look at A now, we kind of have two triangles here, but they're in one. We have this top triangle, and then we have this big ol' honker. Okay? So, this 24, that's the length of this small triangle, whereas 6 is the length of this side. It's not proportional, right? It doesn't look very good. Okay? Just like ACT, it might not always be to scale. Okay? Okay, so, how can we set this one up if we know the triangles are similar? We know these triangles are similar. Where did you get 26? Bless you, let's write that up. Okay? So, okay, so we took before, we took a side of the small triangle over the side of the big triangle. So what's the side of the small triangle? No, what's the side?
24.
24, what's one of the 24?
25.
Wait,
What?
so you have to take one with 30.
Hey, Aubrey just found something. What's the side of this whole side? What's the length of this whole side? 30. 6 plus 24. 24 over 30 is equal to, what's this?
28 over X.
28 over x. Small triangle over big triangle is equal to small triangle over big triangle. So what do we do now? What can we do first, though, with this fraction? We can simplify. That might make our life easier, okay? It's good to look to simplify. What do 24 and 30 can both be divided by? Okay. They can both be divided by 6 and become 4 over 5. Is that a lot less scary to do? Okay, so we have 4 times x is 4x, excuse me, and 5 times 28 is 140. Correct?
Equals 35.
Well, 5 times 20 is 100, 5 times 8 is 40, so 100
Why are
plus
they
40
all
is
over
40.
4?
I'm right now.
Equals 35.
See, it makes sense.
It makes sense after I said it, though.
Well, yeah.
Yeah, that's not
I just wanted to give you like 20%.
Yeah, see that? And like, I've been doing this for how long? So,
You're only 5 years older than us.
yeah, so 5 more years. So quite a
Why would
bit,
you
so.
find that would make
And
us
like all of
17?
them are over
Yeah.
so-
I'd make you guys 18.
You're right.
I'm like 7 years older than you guys.
Alright.
Super duper senior.
Okay?
Yeah, it's like, I only have 5 years.
So x is 35, this side is 35. Questions on that, class?
I'm the
Class A, Class A. Silencio.
Yeah.
Okay, John, Okay, let's look at letter C. Too bad. Okay? I want you guys to do this on your own. Do it on your own real quick. Thank you.
Oh, this is E.
Yo, Gage, where we got for A and B?
They're right down.
Yo. Okay. Not right now. Okay, cool. But in the future, you should do stuff like that. You think you got it? Shush.
Are you sure? Are you sure?
Yeah.
Do you want to
Sound
repeat
I'm
that? Oh, no, seriously, go away.
Okay.
I'm just gonna go dig a hole.
I just need to go dig a hole.
Had to move it.
Yeah, you can't dig with your mouth up in your face.
Stand the LS. Okay.
Apparently.
Hey, help me set this one up, Owen.
Going up. So the dots are congruent. This is at the top.
Yeah.
And then you have to put 5 over 15 so you can figure out the ratios. 1 over 3.
Okay. And then how does that help us?
That's the ratio. So it's just like, if that one's a small one, you know the other one's 3 times as big, so you just multiply it by 3.
Okay, so we can multiply that by 3. You can multiply by the scale factor, find the scale factor. Or we can set up cross multiplication.
Oh, you don't know.
Yeah, no, that's 3 over 9.
Oh, that was supposed to be an A.
Okay.
That was just a really bad A. No, that was actually supposed to be an A, though.
Well, looks like it's a mistake then.
Oh, yeah.
Yo, it's Bad A, not a mistake. That's my normal handwriting. You guys know my handwriting is not good.
Yeah.
Okay? A would equal 9.
with a student that
A
you
was planned.
had great handwriting.
Mine
I
was-
was there when I was tutoring Tommy. You said you had great handwriting.
Oh yeah, I
Who was that?
That's called
Please
a
don't
lie.
kill me.
I think
Oh, okay. Hey, does somebody want to get the fourth? Actually, it's called the practice test. It's in the stack. They're on.
I have a very
Yeah, they just stop.
That's okay. If it hung up prematurely, that's what happened. That's fine.
4-6 or practice test?
It's a practice test.
The phone.
It's gonna be like
the
way
phone
down here.
is not longer.
Yeah. If I'm gonna pass those out. That'd be absolutely amazing. We're not gonna do all of it, but you know. Hey class, Ian's being a champion passing out our review, okay? So as I said, we have a review.
This is a fat stack.
It is a fat stack.
Double-sided.
And it's double-sided.
Oh my god.
Haley, if you're hearing this, this is double-sided.
54 questions.
Okay?
Don't forget your tilde.
Oh.
Fat.
54 I got.
Haley, if you're listening, I'm sorry I didn't get the video. She'll understand, guys.
You didn't have cool socks anyway.
Stop being
sick.
If you hear me, I'm so glad you're not here because it's much quieter.
Wait, what's
Oh,
quiet?
barely,
I'm
but-
so-
Haley,
What?
so
Haley, hey,
my hot chocolate.
Hey class,
Yeah.
there's a lot to not do, and also I have some instructions to walk through with you guys on. So let's look through that first page, please. If you look at number 4, what's the word say on number 4?
Cute.
Acute. I want you to change it to equiangular.
Oh my gosh.
Let's go. I want to make you cry. If that helps make you cry, more for it. Okay. See. Then going on to the second page. Third page. Third page. That big section that's most of the paper. If you look at that line of instruction, the last sentence says explain your reasoning, correct? Okay, that last sentence on the third page, right before 29, 30, and 31, it says explain your reasoning. Cross that out. You just need to say whether it's possible and say the theorem. You don't even need to do a similarity statement because most of them don't have points. Okay? And then the other thing is, flip the page. On this 40 through 44 section, I want you to change the instruction. It says the following triangles are congruent. And then after that, cross out what's left. So, this one was. So on this page right here, if you're where I'm at, okay. So the top says the following triangles are congruent. I want you to cross out what's after that and write in that I want a congruent statement and the theorem. I want the congruent statement and the theorem. We know the triangles are congruent. I want the congruent statement and the theorem you use. So like side, 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 side angle, side, that kind of thing. Theorem you use. So I want congruent statement and the theorem on those. Those are my instructions. Okay, this will be on Google Classroom as well as to which ones we're not doing. Correct. That's why it says 37 to 38 or 48. Yeah.
Okay, which one?
You guys, if you guys need to, I recommend taking a picture, or if you're not writing it down, take a picture of the board real quick that we have later. Or cross them off, or whatever. Or they'll be on Google Classroom as well. So if you need the extra resource, they'll be on Google Classroom as well. Hold on. Hey, I hope you guys have a good weekend. Oh, nice. Good luck. Here.
Mr. Costle, the instructions were what in the congruent statement?
Oh, softball.
And the theorem.
Go to bed early.
Any tips?
You missed it just
Dude, it's
what?
too
Um, pace yourself. I mean, you know, you gotta go. You gotta speed yourself up. You're just, I feel like you're overall.
Yeah.
You have the whole speed up. After. If you have extra time, go back. But do not let yourself get hung up on the question too long. If you don't know it, certainly go back and make sure you don't mumble it in. Because you gotta make sure you keep on track of your numbers. Okay? Yep. Hey, have a great day, everybody. And thank you too. Hey, good luck. Hey, good luck to those competing this weekend and tonight and whatnot.